this lesson, we'll cover your mechanical system settings and also your duct system settings. So before you start to work within any of your Revit model projects, specifically if you're using systems within MEP, you want to verify and ensure the system settings are correctly set. Now, there are a lot of default settings with default values for each of your systems, but you want to review these and apply your own standards or procedures or design requirements based on the customer you're working with. Again, Revit comes preloaded with a lot of good information based on standards from years of practice. But again, you should review this and apply your own guidelines and standards. So to see this information, specifically for mechanical system settings, let's go to the Systems tab on your ribbon, and then in the HVAC panel area right below that, you'll have a flyout arrow down in the lower right. Hovering over that, you'll see the tip Display Mechanical Settings. So let's go ahead and click that arrow to the lower right that reads Mechanical Settings. This will open a new window displaying various information for your mechanical settings. Hidden line values, duct settings, piping settings. Now, some of these are very specific according to the actual system that you're laying out. Some are an overview, such as these hidden line settings. For example, the inside gap, the outside gap, the single line values. These values control what your actual duct work would look like in your rendered models or your models as you look at them within 3D views. So do you want a single line or do you actually want the thickness of the detail? Other settings are specific to the system. For example, your duct settings. If you click on duct settings, you have a listing of your general duct settings and their values associated each. Now, depending upon whether I started a project with a metric template or English template, you would see the appropriate unit for each one. Here, I'm working within a metric template. Below that are angles. This is where you can define and tell Revit whether you want to allow any angle within your HVAC system, or a specific angle, or only specific increments. Below that is conversion. This is where I can set classification settings for my different systems, whether that be supply air, return air, or exhaust air for my main trunk within my HVAC or duct run, and also for my branches off of the main trunk. Below that are your three main system types: rectangular, oval, and round, giving you the variety of sizes currently defined for this type of system within your ductwork. And lastly are your calculations. Specifically, in this case, the calculation used for pressure drop. But you can also apply different ones as well. This calculation is used if you run an inspection analysis against your HVAC system, where of other things, it would measure the pressure drop within the system. Go ahead and click OK. So as a review, in this lesson, we looked at the mechanical system settings. We looked at where to view the mechanical system settings from, and the importance of setting these settings in accordance to your standards, your guidelines, and or your project guidelines. In this lesson, we'll cover air terminals and mechanical equipment. So when you start to lay out your mechanical system, in this case an HVAC system, you'll first want to check or verify your mechanical system settings. Once you have those settings verified or modified to your given project or company standard, you'll next want to start laying out your components for your system. Generally, you'll add in those components first that make up the main part of the system, such as variable air volume terminals or valve terminals, or a heat pump, or an AC unit. So any of these main components you'll typically want to add, and usually these will be level-hosted families, meaning they'll be bound to a level or the floor at which you're adding these. Being that they're bound to that level, you'll want to also assign an offset value so they sit at a specific height above that level. For example, if we were talking millimeters, maybe about 2,800 millimeters above the level it's associated to. Inches and feet, they would be about 9 feet. And that's kind of what we see in our example here on our screen. We have an air handling unit in the yellow, and then we have our main trunk in blue of our ductwork for our HVAC system. And then at the ends of each duct run, you actually have an air terminal or diffuser. For this lesson here, we're going to strictly stick to air terminals and mechanical equipment. Let's look at placing those elements. So we'll start with the mechanical equipment first. To do that, let's go to the Systems tab on your ribbon, and then in the mechanical area, select the Mechanical Equipment button. This will then display in the Properties area all of the mechanical equipment components that are currently loaded within your Revit system. Now, the one we're going to use in this example will be the horizontal high efficiency 7 to 18 kilowatt left return right discharge heat pump. And we'll choose the 11 kilowatt model. And when you do that, it's going to ask you to place this on your screen. You move your mouse around, you'll see it within the cropped window. Now keep in mind, this view we're looking at is cropped on the right, the left, the top, and the bottom. So you'll want to move inside of the walled area to actually see this. Now, don't click yet, because there's a few things that I want to point out. One is, in the properties box, the constraint level. I see it's bound to level 1, which means it's hosted to level 1. Make a note of that. Whatever level or whatever host you host one of these components to, it has to stay with that type of host. Meaning, I can't change this from being hosted on a level to hosted on a wall. Also, it's specific to the type of equipment or component. Secondly is the offset value. Right now it's 0, which means if I place this, it's going to sit right at 0 elevation on level 1. I typically don't want that. So what I want to do is place it at a specific height above that level, in this case level 1. So if I'm using millimeters, about 2800 millimeters. If I'm using feet, about 9 feet. And then click Apply. That'll make sure that the unit now is at that height above level 1. The last thing I want to point out is if you want to rotate this, you can always use your Rotate tool in the Modify area of the ribbon after the fact. Or you can check mark or check the box on the options bar to rotate after placement. That means when you click, you place the element, then Revit will ask you to rotate it. So let's go ahead and place this. Now I'm just going to choose an area over here to the left. Doesn't matter where for this example. Just go ahead and click. That'll place the unit. Now as the unit is placed, since the check mark or rotate is selected, it's going to now ask me to rotate this. And just simply move your mouse 90 degrees one way or the other, and it actually rotates the air handling unit. To quit the actual command, click Modify in the upper left. Now the orientation should be similar to what you see on my screen, with a small portion or a small protrusion on the bottom of the air handling unit. If you click the unit, you see actual attachment areas where I can link in various other elements, such as my ductwork, plumbing work, and I can see that by the symbols and the icons called out around this actual unit. Just go ahead and click off the unit so it's de-emphasized. Now the second thing we want to place is one of our diffusers. We can either place a supply line or a return line diffuser. And you could do the same thing. We could go to the Systems tab on the ribbon. I can click Air Terminal. And then in the drop down in the Properties box, I'll actually see the air terminals that I could use to place. Now the one I want to place in this example is going to be the M Supply Diffuser sidewall. It's a 450 by 200. So I can go ahead and click it, and then move my mouse out to my window or out to my screen. And I'm going to go ahead and place this actual diffuser somewhere below in my model, the actual first unit that I placed. And then simply click. Now I chose not to rotate this one, and therefore it didn't ask me to rotate it after I placed it. I can continue to place additional diffusers if I want to, but if I'm done, just click Modify. One thing to note, you may be wondering, well, why are certain units yellow? Why are certain units blue, or maybe a magenta color, or green? Well, that has to do with the visibility graphics filter specific to this view. To see that, make sure you're not clicked on anything in the property box on the left reads floor plan. Then go down and click Edit to the right of Visibility Graphics. On the Visibility Graphics window, go all the way to the right to the Filter tab. Here's where I can look at the filters, how I currently have them set for Mechanical Supply, Mechanical Return, and then back on Model category, I have an override applied in yellow for Mechanical Equipment. Go ahead and click Cancel. So that's what's dictating the colors for what I see. in my HVAC system in this model. Now, one of the other methods of placing these different types of diffusers and mechanical equipment components is actually from the library directly itself. In the project browser in the lower left, if you scroll down to the actual family section, and then expand families, and then scroll down to mechanical equipment underneath families, expand it by clicking the plus, you'll then actually start to see the units and the other elements that we placed. So if I look under mechanical equipment, second one from the bottom in that list, the WSHP horizontal, but make sure it's the left return unit, and you click the plus to the left of it. Here are the various sizes. To place one of these, simply choose the one you want to place, and then drag it out to your actual window, and then release the left mouse button, and you're holding it at the mouse now. Now again, you can go up and set the offset, and then you can click to place it. This one I'm not going to place, so I'm just going to click Modify in the upper left to exit the command. So in this lesson, we looked at placing air terminals and mechanical equipment. We talked about placing your main system components first, your mechanical equipment, your valve terminals, AC units, your HP units. Once those are actually placed, we then went on to place our different types of air terminals, our air diffusers, our air supply grills. We also looked at various colors and why those colors are actually the colors we see on our screen: yellow, blue, magenta. And finally, we looked at an overall layout of actually placing these elements inside of the view. In this lesson, we'll cover duct placeholders. So looking at the example we have on our screen, we actually see two duct rods. Those are the elements in blue. They come out from the actual mechanical equipment, the yellow boxes, and then they connect into the actual end result, or the diffusers. Those are at the very ends. And you can see those diffusers if I move my mouse over each one and pause. It'll highlight showing me each terminal diffuser. In this case, one on the end of each run of the actual system. What we want to look at is a duct placeholder system. So you may ask yourself, well, what's a duct placeholder system? If I know what a duct is, because I can see it's in blue here, what is a duct placeholder system? Well, the difference between a duct and a duct placeholder is basically the duct is drawn just like you see it. The real shape, the real size of that duct work. The duct placeholder is nothing other than a single line. Now, the single line has similarities and differences to the real ductwork. Duct placeholder ducts can only represent oval, round, and rectangular shapes, or that type of duct system. Whereas ducts, you can have a variety of oval shapes, rectangular shapes, and round shapes, shown at their true scale or how they're actually drawn. Another thing is that placeholder ducts do not have values for things such as the justification for placement, insulation, or lighting. Primarily, it doesn't have these things because a duct placeholder line is typically used just in the conceptual stage of laying out a project, basically where I just need a placeholder or a rough idea of where it's being placed. In comparison to the duct that's on the left, we're going to use the duct placeholder to do the same thing to the actual unit in yellow on the right and the diffuser air terminal on the right. So let's go to the Systems tab on your ribbon. On the right in the HVAC panel, click Duct Placeholder. Now, before I click anything, the first thing I want to verify is, well, what type of duct do I want to apply or use here within my system? If you click the drop-down in the Properties window, I'll see the actual components or ducts that are currently loaded. I'm just going to use the rectangular duct mitered elbows taps in this example. The second thing I want to do is verify the width and height, and also my offset from my reference level or hosted level. So my reference level is level 1. I want to verify in the drop-down that my offset is 2800 millimeters. For those of you using inches and feet, that's about 9 feet. Now, with that information verified and set, I can actually start to place my duct placeholder line. I can place this with two methods. One is an automatic connect method, connecting to points on my diffusers and on my air handling equipment, or I can do a manual placement. I'm going to use the automatic method. So let's move our mouse over the diffuser in the lower right. Pause your mouse over the top side of that diffuser, and you should see a little snap or a little symbol appear over the point or connector on that diffuser. This is the intelligence of the diffuser itself that will interpret what type of duct would connect to it and where it would go to connect to something else. In this case, though, we're just drawing a single line because it's a placeholder line. When you see that symbol, go ahead and left click on it, and then start to move your mouse or drag your mouse. And when you drag your mouse, you see a green line being pulled away. This is the placeholder duct line. Move into the yellow shape on the very right on its bottom, and you should see the same symbol appear in that area. Again, another point or a connector allowing this supply diffuser to be connected to this actual unit. Now, if you try to connect the wrong type of diffuser to the wrong unit, Revit will notify you that you have a mismatch in your system. In this case, they match. So when I see this other symbol for the point the connector, simply left click. And what Revit will do is calculate the path based on the settings for your mechanical systems. So again, that's why it's important to set your mechanical system settings, or at least verify those before laying out any type of mechanical equipment. Now I can continue to create additional duct systems at this point, but I'm done for this example. So let's click Modify in the upper left. Now, to see some of the differences between the placeholder duct on the right and the actual true duct on the left, let's go ahead and click on each. So on the placeholder duct on the right, I'm going to click the little angled horizontal line that represents the duct. When I do that, I see the dimensional values on my screen. And over on the left in the property area, I see it's attached to level 1. It has an offset, but I don't see any justification values here. Also, if I were to scroll down, I won't see anything for insulation or lighting. Click Modify. Now, let's click on the same element on the left for the duct. Again, I see dimensional values on the screen, very similar. The area on the left shows me the information for the duct, but now I also see my justification of how this is being justified, where the dimensions are and where it snaps to each piece of duct work. So there's a middle and a center justification. Also, if I were to scroll down, I would see information for insulation and lighting. So these are just some of the areas pointing out the differences between a placeholder duct and also a regular duct. So as a review, in this lesson, we looked at duct placeholders. We discussed what the difference is between a duct placeholder and a regular duct. We also looked at where to place these duct placeholders from, the Systems tab and the HVAC panel. We looked at the settings for the duct placeholder, offset values from the finished floor, also the differences between the duct itself and a regular duct, meaning justification and lack of insulation or lining values in the placeholder duct. And lastly, we talked or showed how you can actually convert a placeholder duct to a regular duct. In this lesson, we'll cover system ducts. Looking at your Revit model right now, you can see in blue we have an HVAC duct system. On the very right, you have a green line. Move my mouse over that green line. This green line actually represents a placeholder duct or duct placeholder system. Basically, it's the same thing, except it's only being represented by a single line. Typically, it's used in conceptual design if you're just conceptually laying out that duct arrangement or that duct line. It still does connect to your diffusers and your air handling units. But the difference is it doesn't have justification values, simply because it's just a line. It also lacks information for insulation or lighting, whereas a regular duct would have that information. But as far as placement, if I'm manually clicking points, it is placed the same way as a regular duct. So in this lesson here, we're going to look at placing a regular duct from a diffuser to our air handling unit. And we'll use those symbols on our very left. So to place our duct, let's go to the Systems tab, and then on the left in the HVAC panel, click Duct. When you start the duct command, in the first area on the left in Properties, this is where you can choose the type of duct that you want to place. For this example here, we're just going to use the mitered elbows taps duct. These are the ducts that are currently loaded into this Revit project. I can always load more in if I need to. Note, the placeholder duct displays the same information in the properties as far as what type of duct you want to place. Now, you could choose anything from oval-shaped ducts, round ducts, rectangular ducts, just all depends again on what you have loaded in your system. Now, with that selected, before I click anything, I want to verify a few things. First, my width and my height of the actual duct itself. And then also, I'd like to place the offset from the current level that this is bound to. Right now, it's bound to level 1. If I had the offset set at 0, the duct would basically go from each of these units, the air handling unit and the diffuser, all the way down to the ground and then up to where these two units sat or hung from the ceiling. However, I want this to be up there in line with those, so I'm going to set my height at roughly 2,800 millimeters or 9 feet above level 1. Now, with those values set, I'm ready to start my duct run. To do that, simply move over one of the ends of the actual diffuser. In this case, I'm going to go to the top of the diffuser on the very bottom of your screen. When you hover over it, you should see a point icon for a connector appear. When you see that appear, go ahead and left click on that, and then start to drag your mouse. Now, based on the duct type and the connector type, the duct will size appropriately, and you'll see that duct being pulled apart or pulled away from that point on the diffuser. Just simply move your mouse up to where it should connect on the air handling unit. That's the item in yellow. You'll see the same symbol appear again for the point in the connector. When you see that same symbol, left click. What Revit will then do is calculate this duct run from the first point to the second point, applying the appropriate angles based on the default settings that you set up or originally had set up in your mechanical system settings. So again, that's why it's important before laying out any piece of ductwork or any air handling unit or plumbing unit or piping unit to verify you have your mechanical settings correctly set. So basically, I just drew a piece of duct or a duct run. Now I can continue to do this, but right now at this point, I'm done for this example, so click Modify on the toolbar in the upper left. So this created that duct from the actual diffuser back to the air handling unit. Now, one thing I want to note about the placeholder duct on the right, you could also create a duct run from it, or you can convert it. For example, I can choose each piece of this placeholder duct individually, or I could choose to window in parts of this actual placeholder duct. When I window those in or manually select those, on the ribbon in the upper right, you'll have an option for Convert Placeholder. When you select Convert Placeholder, it will convert those placeholder lines that you select, either individually or by windowing them in. It'll convert those elements into their appropriate regular duct. And again, I could do these one at a time, or I can do them all at once. And then it would convert those into really the same thing that I created on the left. But again, the actual placeholder duct is used for conceptual design, where your regular duct is used more for actual design when you know that information and where I need to place it. Now, to look at the properties of the duct itself, go ahead and click on any piece of the actual duct work. When you do click on it, you actually see the dimensional values and the connection points, and those are actually determined or placed based on your horizontal and vertical justification settings in the constraints of the properties on the left. Those two values, the horizontal and the vertical justification values, are not present in placeholder ducts. Also, you have a variety of other information for the ducts on how they're connected, how they go together, and how they're aligned or connected to the other handling units or diffusers. Go ahead and click in the background to deselect anything. So as a review in this lesson, we looked at how to create a regular duct run. We looked at, first of all, starting the duct command from the Systems tab, choosing the correct duct type to use, and setting values for the duct, such as offset from the level it's associated or hosted with. We then used the manual method of clicking points, but automatically connecting those points from our diffuser to our actual air handling unit. We also looked at how to convert a placeholder duct line into a regular duct. And lastly, we looked at the properties of the duct and how their alignment values are set and the other properties listed for the duct and how it differs from a placeholder duct. In this lesson, we'll cover duct insulation and duct lining. So in our example on our screen, we have 3 duct systems. We're going to focus on the outer 2. Now the duct system all the way on the left, but what I'm moving my mouse over right now, is made with a regular duct type, or regular duct system. The one on the very right is made with a placeholder duct or a duct placeholder system. Now technically both are very similar. They're made from duct types, which have duct properties and parameters and specific values. But a few differences are the duct placeholder system on the right. One, it doesn't have justification values of how it's placed, where the duct system on the left does. Also, the duct placeholder system on the right does not have the ability to add duct insulation or duct lining. If you click on one of the lines in the duct placeholder system, the properties for that system appear on the left, at least for this duct. If you scroll down in the property area all the way to the bottom, I do not see any entries for duct insulation or duct lining. Click Modify to deselect. Now, on the duct system in the left, click the same element for the duct, the one that's on the horizontal angle. Dimensions will appear for it, and the properties appear. Now here, you see the horizontal and vertical justifications for this element, which you didn't see for the placeholder duct. And if you scroll all the way to the bottom of the property area, you see 2 areas, one for insulation and one for lining. So again, you can only add insulation and lining to duct elements that are actually created with a duct or a placeholder duct that's been converted to a duct. So let's look at how we can add insulation or lining to a single segment of the duct run or the entire duct run or duct system, basically depending on what you choose. So I chose this one element right now. If it's deselected, just go ahead and select it again. When you select any element of a duct system, i.e. a piece of duct, the ribbon will change, and on the very right, you'll have an option for duct insulation and duct lining. To add either one, all you have to do is click the Add button, again for Add Insulation or Add Lining. In this example, let's click Add Insulation. Now again, the first thing you would want to do is make sure you click a piece of ductwork so you see this displayed. Once you click Add Insulation, it's going to ask you, well, what type of insulation do you want to add? In this example we're using here, we only have one type called default. And we only have basically a thickness by default called 25 millimeters. That's roughly a little over 1/2 inch, 3/4 of an inch. So you could change the values to whatever you want, or I can edit the type and add a new type. For this example though, we're just going to click OK. Go ahead and click OK. And that will actually add insulation to this segment of duct. Now, if you zoom in closer on this duct segment, you'll actually see a dashed line that represents that insulation or lining, depending on what you add to this duct work. I'm just going to zoom back out. Now, since the insulation or lining has been added, the ribbon now changes, giving you additional options, where you can come in and actually edit the insulation, or you could remove the insulation. So if I want to remove the insulation here, I can just simply click Remove Insulation. It's going to ask you to verify you want to remove that from the actual duct segment or duct system, and then it's technically removed. And again, I can repeat the same process using the Add Lining, where it will ask me again what type of lining type that I want to add and the actual thickness. Again, I can edit the type or add a new type or change the thickness. Let's go to click Cancel in this example. So as a review, in this lesson, we looked at duct insulation and duct lining. We looked at the 2 examples of duct systems or creation of ducts, one using the duct command and one using the actual duct placeholder command. We saw that the duct placeholder does not have the ability to add duct insulation or duct lining. Only ducts created with the duct command can, or a duct placeholder duct, if it's converted to a duct, can actually add duct insulation and duct lining. And then we looked at how to add the duct insulation or lining to the duct itself, either its segment or the systems, how to edit that duct insulation or duct lining, and then finally, how to remove that duct insulation or duct lining. In this lesson, we'll cover modifying ducts. Well, there's a lot of things you can do to modify a duct. One is you could actually stretch the duct length or move the position of a duct. You can also change the entire duct itself from its current duct type to a different duct type. Well, let's look at that one for example. So the duct we want to change is basically everything blue on your screen. I'm going to window in the duct work itself by creating a window and dragging my mouse left to right, so everything in blue is surrounded. With everything in blue selected, I now see the part of the ribbon on the very top right, giving me the various tools to look at, edit, modify, analyze the different types of the duct elements. Let's look in the Edit section. We have three icons here in the Edit section: Justify, Change Type, and Reapply Type. Change type will allow me to change the type of this duct system or a duct segment, depending on what you click, to something different. So let's go ahead and choose Change Type. This will display now the types that I can choose from within this current Revit project. Let's simply change this from minor elbows taps to minor elbows T's. When you select that, you'll notice that the actual Revit model itself, in this case for the duct system, changes. To deselect this, simply just click Modify in the upper left. And now we have, in this case, converted or changed the actual duct type. Now another thing you could do for modification is actually moving different parts of a duct segment or a part of a duct element, such as the diffuser or a component. Let's go ahead and zoom in on the bottom part of the actual duct itself. Now I could, if I wanted to, click on the right terminal for the air diffuser, and when I do that, I'll actually see one of my point controls, or connectors. If you mouse over that, you'll see a word drag, meaning you can simply just hold the left mouse button down and drag this element in a distance that you want from that actual current position. Then release. I can do the same thing for the ductwork as well. If I select the duct segment, I also have the actual connecting points that I can drag and reconnect, again with the point connection symbol, to the actual diffuser, or in this case, air channel. Now you also have a few other icons on the actual ribbon, depending on what you choose, either a duct segment or entire duct system. If you choose duct segments and/or duct systems, you actually have a Justify icon on the ribbon in the edit bar. This will allow you to align various segments with one another or to an imaginary construction line or to an edge of something that exists, as it's depicted by these circular tubes in the Justify tooltip. Go ahead and click on the area in the white background to deselect. So in this lesson, we looked at modifying ducts and duct systems. We looked at ways to select the entire duct system and modify its type. We also looked at the drag capabilities to drag duct components, duct diffusers, duct mechanical elements, and duct segments themselves to new positions. We also looked at ways to actually view and modify the actual duct elements. In this lesson, we'll cover duct fittings and duct accessories. So you may ask, well, what is a duct fitting and what is a duct accessory? If you look at the example I have on my screen of my duct system, I have a main duct line segment and two branches coming out at the very bottom. The two branches have diffusers on the end of them, but the main trunk of the duct system coming down has an open end, and I really need to cap that off. So I would want to place an end cap on that main trunk. That end cap is an example of a duct fitting. What's a duct accessory? Well, maybe I need to place a damper or a filter inside of my duct system. A filter or a damper is an example of a duct accessory. Both duct fittings and duct accessories can be placed inside of your HVAC duct systems from the System tab inside of Revit. So let's go to the Systems tab. On the Systems tab, in the actual HVAC panel on the left, you have two icons. One, duct fittings, and the icon below duct fittings, duct accessories. Let's place that end cap first for the duct fitting. So go ahead and choose duct fitting. Now, just like any other component, you have the properties area on the left where you can choose which element you would like to actually load in or work with in this Revit model. If the element didn't exist, you could always load the family in of a new component to use. For this example, though, we're going to use the rectangular duct end cap standard. So as I move my mouse around the screen, I can see I'm holding that end cap, but I really need to place it on the bottom of the run of the actual trunk. And you can see it's not aligned. Well, don't worry, it will align itself when you move it into its final position. So I'm going to move my mouse holding the end cap over the end of the run of the duct. And once I move into that area where it needs to be placed, you'll actually see that ductwork aligned, where in this case, the end cap aligned with the ductwork. Now I'm going to snap it to the end point. So when it aligns itself, just zoom in or zoom out. When you see it aligned, go ahead and left click. This now adheres that end cap to the end of the duct segment in my duct system. Again, I can keep going and placing additional end caps, but I'm finished for this example. So click Modify in the upper left. Now the next example is to place a duct accessory. And maybe in this example, what I would like to actually place is a balancing damper inside of my duct system. So let's go to the duct accessory command. Again, on the Systems tab in the HVAC panel, click on duct accessory. Now, if you don't have any accessories loaded, or for that matter, any other thing you place, if it's not loaded, Revit will ask you, well, do you want to load something? Or do you just want to exit the command by clicking no? Well, yes, we need to load an accessory to place inside of this model. So click yes. Now, if your system already has the accessory loaded, you won't see this screen. You'll just go to place that accessory. But since we have to load an accessory, let's go to the duct folder, double click it, then go to the accessories folder, double click it, dampers, double click it, and then the one we want in this example will be the first one, the balancing damper rectangular, since our duct work is actually rectangular in shape. Click open. Now, when I open this, it actually loads it into my current Revit project. I see the properties for this component in the properties area, and I'm now holding it ready to place inside of my duct work. I'm just going to move my mouse over top of my actual duct run, and I can move my mouse vertically up and down, but I want it aligned to the actual center line or reference line inside of my duct work. And then I'm just going to use the nearest snap. So just left click, and that will place, in this case, that balancing damper inside of my Revit duct system. Again, I can continue on to place additional ones if I wanted to, but for this example, I'm done again. So just click Modify in the upper left. Now, any of these elements can be deleted, removed, and modified. Simply just by clicking on each one, you can edit, change it, or move it, again, using the actual control points, and place it in a different location inside of my duct system. So as a review in this lesson, we looked at duct fittings and duct accessories. We talked about what a duct fitting is and what a duct accessory is. Fitting being an end cap, for example, and a filter or damper being an accessory. We then looked at how to place each one, placing the duct end caps, which is an example of a fitting, on the end of a duct run, and then loading in the actual damper as an example of a duct accessory, and then placing it inside of our Revit duct system. In this lesson, we'll cover duct systems. So you may ask, well, what is a duct system? What does a duct system contain? Well, a duct system contains all the elements within that physical system. So it could be the component that supplies the air to the actual system. It could be the actual diffusers or terminals at the end of the system that the air comes out of. And it could be anything in between these elements. So the actual duct work, duct accessories, and duct fittings. So before you actually start to create all of these elements, you really need to define or should define a duct system. But first, you want to place a few components that base the duct system on. So in this example here, I've already placed 5 elements we'll use in this duct system. Four things I've created are the air tunnels, the diffusers for which the air will come out of. The yellow box at the top is the actual mechanical equipment that supplies the air to these diffusers. So these five elements I want to add to my duct system before I start to create duct lines and duct accessories and actual other duct elements. So to get started with this, the first thing you would do is create your actual starting point of some duct components. Once you have a few duct components placed, you can create the duct system. That step process would be to first click one of these elements. So I'm going to start where the air would be supplied at and choose the actual mechanical equipment supplying the air. When you select this, you'll actually see on the right side of the ribbon a Create Systems panel. Now, depending on what you select, it will tell you what type of systems you can create based on its capabilities. So this mechanical piece of equipment has the ability to have a duct system and a piping system. For this example here, we're going to choose duct to create a duct system. So go ahead and select duct. Now, I'm presented with a new screen. It's telling me or asking me, well, what type of system? Supply air or return air? Well, I'm going to define a supply air system and now give the system a name. I'm going to choose just the default name here, Mechanical Supply Air 32, or it could be whatever you want to name it. Now the system editor that I can check mark in the checkbox below would allow me to add things or components to this system. I'm not going to check mark it right now because I'm going to launch this editor from an icon on the toolbar. Just go ahead and click OK. Now what happens now is the system is created, System 32, within Revit. And I can see that in my system browser if I want my system browser at this point. But only one component, that one we first selected, is part of the system. I need to add these other four terminals or diffusers to the system. So with the actual original component still highlighted, if it's not, just click it again, and then you'll see the actual system tools area on the right. I'm going to click Edit System. This will open up a new part of the ribbon, allowing me to add or remove elements to this system. Well, I want to add things to the system. So what's currently in this system is emphasized in bold or outlined in black. That's the one unit in yellow. The Add System button is selected on the ribbon. Now all I have to do is pick elements that currently do not belong to the system. For example, the four terminals, the diffusers. So just go ahead and select all four by left-clicking on them. They'll then be added to the system, and I see a total number of elements within the system. You also could select from a drop-down if you wanted to pick other elements to add to the system, such as mechanical equipment. In this case, I'm just picking the four diffusers. You could also use Select Equipment from the actual ribbon. Now, once you're done adding elements, in this case components, to the system, just click Finish Editing System. Now I have this new system defined with 5 elements in the system. To see this in the system browser, let's go to the View tab on the ribbon, all the way to the right to the user interface, and then checkmark System Browser. In the system browser, you can expand Mechanical to look at the mechanical system. And then since we tagged this as a supply air system, expand Supply Air. Scroll down to where I see System 32, for supply air. When you select it, it should window in all the components within the system. If I expand that inside of the browser on the right, I see all four of the diffusers that I selected, plus the actual supply component, the yellow box, if you will, supplying the air to these diffusers. To deselect, simply just click anywhere in the background to deselect any element you currently have highlighted. So as a review, in this lesson, we looked at how to create duct systems. We first off talked about what is a duct system and what does a duct system contain. Basically all of those elements, starting with what supplies the air to what diffuses the air and everything in between. We then talked about first creating a component or a few components inside of your Revit model and using one of those as the basis to create the system. You then create the system, name it appropriately, and add the other components to that system. From there, you can view this information in the system browser, and then you can start to route your actual HVAC lines either manually or automatically within the system itself. In this lesson, we'll cover a method to automatically create duct layouts. Now, in previous lessons, we looked at manual methods of creating ductwork from a supply component to an end result, such as a diffuser, basically clicking point to point. In this method, we'll actually select all of the elements within the duct system and then tell Revit the best route or ductwork between those elements or components. For example, on my screen, as I mouse over these, I have actual 4 air terminals or diffusers already placed. I also have a mechanical equipment element or component already placed as well, which will supply the air to these diffusers. So my next step to automatically create the ductwork going from the yellow box or the supply component to the diffusers is to select all of these components. So to do this without anything selected currently, I'm going to window in my 4 diffusers. Then I'll hold the control key and choose the yellow box or the mechanical equipment at the very top. This will highlight all 5 items. Now you could window everything in and filter out the items you don't want, or you could use the method that I used. Either way, select all 5 elements. Now with these 5 elements selected, the ribbon changes, and on the top right in the layout area, you have 2 options: generate layout, and you also have generate placeholder layout. Well, from previous lessons, we know that the placeholder is really a singular line for your ductwork, but it lacks any justification measurements, horizontal and vertical. It also lacks lighting and insulation, but that could always be converted to a regular duct system. In this example, though, we're going to use generate layout. This will produce the actual duct system in its full defined content, including the actual duct linings and duct insulation. So let's go ahead and click generate layout. If you already have a system defined for this actual layout, go ahead and select it. If you didn't, you could just choose unnamed and then later on rename it. I already have a system created called Mechanical System Air 32 for this example. So I'm going to go ahead and select it and then click OK. Now with that selected, the Revit ribbon will actually change and display the actual, in this case, automated method of icons to create this duct system. So right now the Solutions button is selected. And on the Options bar, I have a couple arrows to allow me to arrow through the solutions of what Revit is telling me how it sees that this ductwork should be run. So right now you see placeholder lines, and it's defining basically how it would like to actually run this ductwork. I'm going to mouse over the right arrow and forward to the second solution. And I can see it's another option of how Revit is interpreting how the actual ductwork should be run. Third option is another option. Fourth option is probably the one I want, the most efficient. But let's look at the fifth option. Not really what I want. So let's back arrow to the previous selection. Now this is the layout that I'd really like to use. But before I click Finish or anything else, I'm going to click the Settings button on the Options bar. This will allow me to verify the settings for the main trunk of my ductwork and size. So I could change this right now from its current value and its current offset from level 1 or the finished floor. I'm going to leave these as is. For the branches that come off the actual main run, I can change these values as well, where I can change the duct type and its offset. Right now it's set to use flex duct type. Maybe I don't want that, so I can actually select in the value box on the right, and I'm going to choose none. So right now, the actual duct type for the branch will be the exact same as the main. Now you have a few other buttons on the top where you can actually add elements or remove elements to the system. You can also place a base if you didn't have a base to define the flow. Where we already have one, so we don't necessarily need to do that. You also can edit the actual layout manually, being able to draw lines, remove those layout lines around. For this example, though, we're going to accept solution 4. I'll move my mouse where it says 4 of 5, using the right arrow and left arrow to get to that. And this is what we'll actually use. The solution type only set is network. You also have perimeter and intersections. For right now, we're just going to use network. And now I'm ready to create this actual automated method of the system. So just click Finish Layout. What Revit will do now is calculate the actual duct run based on the placeholder lines and start to draw the duct from its actual yellow box or the supply area all the way through to the actual end diffusers. Now the message that comes up that I see, the warning, actually is stating that here at the very end, I do not have an end cap. So I would want to place an end cap on that actual end run. You can also look at some of the other calculations being defined by the wrong side or location, and I can flip-flop those to make them in the same location or the same orientation. I'm just going to X out of the warnings for now. Now, looking at this, I've actually placed the duct system using an automatic method. I can now go in and change any of these elements just by simply selecting on each segment, and I have the full control to modify any of these elements as I choose or as I see fit. To see this in 3D, over on the left in your project browser, in the subheading HVAC, double-click the 3D view typical room WSHP. This will show what we just created in 3D. Now again, the colors from a previous lesson are set by filters based on the content type that's actually in this view. And as you can see, we've created now a duct system based on an automated method of creating this from a supply unit to the end diffusers. Go ahead and close this 3D view to go back to the main plan view. So as a review, in this lesson, we looked at an automated way of creating duct layouts. First off, we talked about what needs to be set or drawn. In this case, the supply unit, valve box, or an AC unit. In this example here is the yellow box or the yellow square we see at the very top. We also needed to define the end result, or the diffusers, and I had 4 in this example. And then to actually use the automated method of creating ductwork, we selected all 5 of those elements. With all 5 elements selected, we chose the placeholder command to create actual placeholder layouts of this actual duct work. Now again, we draw placeholder lines originally, but then it interpreted those into the actual duct work themselves. Other options we saw were the different solutions at which Revit calculated this layout for the duct work, from the actual component that's supplying the air to the actual diffusers. We chose the solution 4 as the result we would like automatically created. Last step was to automatically create this, and then we looked at the actual model in 3D.